वर्कआउट करेंगे some of the important name reaction from the chapter aldehyde, ketone and carboxylic acid from class 12। और हम लोग जो पहला नेम रिएक्शन इसमें कर रहे हैं इस चैप्टर से बेंजोइन कंडेंसेशन। और इस बेंजोइन कंडेंसेशन में होता क्या है, दो एल्डिहाइड लेना है और ये जो एल्डिहाइड है इसके पास अल्फ़ा हाइड्रोजन नहीं होना चाहिए। द एल्डिहाइड्स विच नॉट हैव अल्फ़ा हाइड्रोजन टेकन अंडर कंसिडरेशन, बेसिकली aromatic aldehyde, not aliphatic. So 2 molecules of aromatic aldehydes has to be considered which do not possess any alpha hydrogen atom, and when they interact with alcoholic potassium cyanide, alpha hydroxy diphenyl ketone obtained, which is known as benzoin, and the reaction is known as benzoin condensation reaction. On your screen you can see that two molecules of benzaldehyde taken and it undergoes interaction together through the condensation process and form alpha hydroxy diphenyl ketone, which is known as benzoin. Now we'll discuss about the mechanism of this reaction, how this reaction is mechanized step by step. In the very first step, alcoholic potassium cyanide dissociate and form Cn minus ion, which behaves like nucleophile. This Cn minus ion start to behave like nucleophile, and benzaldehyde structurally represented carbon oxygen bond contains 5 electron and oxygen atom is more electronegative. Therefore, the displacement of 5 electron is taking place towards oxygen atom, and this makes the central carbon become electron deficient, as a result of which Cn minus interacts this electron deficient carbon atom and form this structure. Now after this process, the process is reversible. O minus, O negative part interacts with the H part, and the carbon hydrogen bond, which consists of one shared pair of electron, displays towards the central carbon atom as it's shown in the arrow diagram or arrow notation, and as a result of which the transformation will be like this. C6H5 carbon has acquired two unshared pair of electron and negative charge, and O minus interact with the H form hydroxy, and Cn structurally represented as C triple bond N. Now the when unshared pair of electron migrated towards the carbon-carbon bond, then the displacement of pi electron of carbon-nitrogen bond is also taking place, that you can see, and consequently the structure will be like this. This is the so-called structure. This is the structure that you have obtained, and therefore we can say that this is carbon ion, and this carbon ion is resonance stabilized. This is the very first part, and in the next part, attack of carbon ion to the second molecule of benzaldehyde. This is the carbon ion part, carbon ion part contains one unshared pair of electron reach migrated to the electron deficient carbon, and this type of structure obtained. Now again oxygen minus interacts with the H part of OH and shows the structure like this. This is that structure. This is the structure. Now O minus consists of unshared pair of electron displaced towards the oxygen carbon bond and nucleophile removing out, and it results the formation of desirable product. This is that desirable product. In class 12 mechanism is not required, but I have already mentioned. So this is benzoin, and benzoin means alpha hydroxy diphenyl ketone. Hope you understand this. Now another reaction, that is Perkin condensation reaction. Perkin condensation is also related to the Claisen-Smith reaction. It involves the reaction of an aromatic aldehyde with an aliphatic anhydride in presence of sodium salt of the carboxylic acid, for which the anhydride has been derived as the base, results the formation of condensation product, which on hydrolysis with boiling water produces alpha beta unsaturated acid. Now let's see how the reaction takes place. This is simply benzaldehyde that you can see, and this is acetic anhydride. In short, acetic anhydride can be written like CH3CO whole twice O. This is for acetic anhydride or acid anhydride. The reaction is carried out in presence of sodium acetate, and what happens from this CH3 part, two hydrogen atom is removing out, which interacts with oxygen and form water. This is that water removing out, and addition product is obtained. Removing out, and the product become not addition, C6H5CH CH डबल बॉन्ड, यहाँ जो CH3 है वो भी क्या हो गया CH, और सारे पार्ट को आराम से लिख देना है। और जब इसको हम लोग बॉयल करेंगे वाटर के साथ, तो ये दो पार्ट में ब्रेक हो जाएगा, C6H5CH डबल बॉन्ड CH C double H, that is cinnamic acid and acetic acid. So this is the Perkin condensation reaction. And the last but not least, Neuville condensation reaction. This condensation reaction is similar to that of base catalyzed aldol condensation. It involves the interaction of carbonyl compound with active methylene compound, and in presence of a base like pyridine or piperidine, and product will be alpha beta unsaturated compound. On your screen you can see that this is the carbonyl compound, everybody knows about it, and this is active methylene compound. So what are active methylene compound? When CH2 group will be attached with the electronegative group or electronegative atom, which may be of similar type or different type, in that condition Neuville reaction takes place, and such type of compounds are said to be as active methylene compound, and the reaction is carried out in presence of bases like pyridine or piperidine. Now what happens, just observe it. In presence of base, there will be removal of water and the rest part simply attached, and this is condensation product that you can see on your screen. Electron withdrawing group may be of similar type, may be of different type, and there is a example CH3 CHO acetaldehyde reacts with malic acid, H2 and oxygen, water. There is a water on at the bottom of arrow sign, and product is CH3CH double bond CH, H2C become C, CH3CH double bond C, C double O H. This is the condensation product, undergoes decarboxylation. The decarboxylation reaction involves the removal of carbon dioxide, and as soon as carbon dioxide is removing out, we get CH3CH double bond CH, C double O H. This is alpha beta unsaturated carboxylic acid, alpha beta unsaturated carboxylic acid. There are some more examples are given that you can easily use to show the Neuville condensation reaction. That's all for today. In our next class, we'll discuss some more important name reaction. Till then, thank you and goodbye.